Hello and welcome to this video for the students of Mathematics for Business and Business and Finance and for students of Math Applications. This is for the Chapter 2 drill problems, the odd-numbered problems. These are the ones that were assigned in your study guide. And so without further ado, I'll just continue on, try to get as many done as I possibly can within, say 10 minutes. If you have any questions, feel free to call and speak with an instructor or email them. And if you, if you need to move around, you can always pause and replay the video if you have to, in order to understand the concept. And of course, fast forward and rewind in order to find the place where you're at. All right. Enough of my babbling here. So, okay, let's move on to the first problem here. Let me get myself set up. All right, and I need to get myself an ink pen. All right, here we go. Okay, relatively simple. It says identify the following type of fraction. So this is a proper fraction. Okay. If you don't know the difference between proper and improper, then obviously go back into your text and see the difference. Okay, next one, 2-3. Again, 14 over 11. This here is a an improper fraction. Why is it an improper fraction, you might be wondering? Well, the numerator should be less than the denominator, okay? In the previous slide, let me go back up. You see how 6 is less than 7? Okay, so that makes that a proper fraction. But when you have 14 over 11, your numerator is greater than your denominator. So what you really should do is you divide the 11 into 14 and you get 1, and that'll give you 3 left over 11. And that would be the way you actually should write this fraction. That's why this is called improper. It's not that you can't use it, it just should be converted into its correct form over here. Okay? All right, 2-5, again, an improper fraction because the numerator is greater than the denominator. All right? And this should be rewritten. Well, 15 goes into 92, let's say, I don't know, 7 would be 7, that's 35, 10, that's 100, so 6, so 15 times 6, 30, okay, at 90. All right, so we have 6, that, as a whole, 15 goes into 92 6 times, and that leaves me with 2 left over, and bring down my 1, 21. 15 goes into 21 one time, that would give me 6 left over. So I would have 6/15. Okay. All right. I know I did that fast. Let me walk through it. I mean, that was my thought process, and that's how I do these problems, but let me go through it just a little bit easier here, okay? All right, so 15 goes into 921 how many times? Okay, 15 can't go into 9, goes into 92 6 times. 6 times 5 is 30, carry my 3. 6 times 1 is 6 plus the 3 gives me 90. Remainder of 2, bring down the 1. 15 goes into 21 one time, so that's 15. Remainder 6. So the 6 becomes my numerator. The 15 is my denominator. And of course, how many times it goes in? 61. Okay? Again, if you have any questions, feel free to contact an instructor. All right, let's see here. Drill problem 2-7. Convert the following to an improper fraction. Okay, so in that last one, I was converting to a proper one, but to convert into an improper one, we do just the opposite. We end up taking the 19, because that's a whole number, and since we're looking at this in thirds, we multiply by 3, so that's 27, that's 57, and we had a 2 as a remainder, so we add the 2, that gives me 59. So I've converted into 59 over 3. Right? Again, this here is a whole number. So how many thirds, since we're looking at the denominator in thirds, how many thirds are in 19 as a whole number? Well, 3 times 19 is 57. And we had the remainder of 2. So we add that. That gives us the 59 as our new numerator. Of course, we're just going to bring down the denominator. Okay, next one. 2-9. It says reduce the following to the lowest terms. Show how to calculate the greatest common divisor by the step approach. Okay, all right, now, if I was going, this is me, okay? This is not the book, all right, but this is how I would do it. Reduce the following to the lowest terms. So what I'm looking for is, I'm looking for a number that is divisible into 44 and the 52, the same number of times, okay? 1, obviously, you end up with 44 and 52. 2, you end up with 22 and 22. If I divide 2 into 44, I get 22, but then I'd be able to divide 2 again into the 22, so that's not a good number, right, because I can reduce it by more. 3 is not a good number. All right, 4 can go into 44 11 times, right, so 4 can go into 44 11 times. Can 4 go into 52? Yes. 4 can go into 52 13 times. Okay, so what I'm doing here is I'm taking 44 and I'm dividing that by 4. I'm getting 11. And then I'm taking 52 and dividing by 4, and that gives me 13. So I have 11 and 13. Can I find another number that can go into those? No. I mean, just 1 and 11, 1 and 13, but obviously 2 all the way up through 13, so I've reduced to 11/13. Okay, now it says show how to calculate the greatest common divisor by the step approach. So let me erase all of this and we'll use that method. Okay. I'm presenting the different methods because they are different methods. Oftentimes there's more than one way to do something, and whatever is more comfortable for you. I just showed you what's more comfortable for me in order to be able to reduce to the lowest terms. However, notice that what I did was I just went and started with number 1, 2, 3. Actually, I just kind of like look at prime numbers, or I just do trial and error and try and guess at a number and see where it lands for me. But doing it this way will give you a more structured approach. So let me show it to you. All right, so I'm going to take, I'm going to take my 44 and I'm going to divide it into 52. Okay, 44 can go into 52 one time. That leaves me with 44 and leaves me with an 8. Okay, so now I take the 44 and I divide it by the 8 here. Okay, 8 into 44 can go 5 times, which gives me 40. And that leaves me with 4 left over. Okay, so now I take the 8 and I divide by 4, and that goes into a 2, 8, so 0. So my lowest common divisor is going to be the 4. All right, so I would then go and I would say, okay, 44 and divided by 4 gives me 11, and 52 divided by 4 gives me 13, and so I have 11 over 13. Right? So with this method here, all right, you know, the step approach, this is doing the math in order to be able to find what your lowest common divisor, your greatest common divisor is going to be, which would be 4. And I ended up doing several steps. Again, me personally, I'm going to erase all of this, and I'm just going to walk through the mental thought process for myself here. You know, I have 44 and I have 52. Well, in my mind, I'm kind of like going, okay, you know, what two numbers can make up 44 and 52? You know, if I go and I say, you know, 11 doesn't go into both of them, right? That's too much. 5 doesn't go into both of them. 3 go into 44. 1 and 3 into 4 goes one time. I have 14 left over, so 3 doesn't go into 14 equally. You know, two goes into that, but like I said, if you go 2 and 44, that leaves you with 22, and then I'm going to end up dividing. I can divide 2 again, so I know 2 is wrong. Okay. I just said 3 doesn't go in evenly. Well, 4 can go in the 44 11 times, and 4 can go in the 52 13 times. It was just that simple. I mean, it's a trial and error method that allows me to work through these very, very quickly. I mean, we're talking about two small numbers, but what if we were talking about huge numbers, you know? And remember, the reason why in a textbook you have small numbers is so that you learn the concept. But out in the real world, you know, if you're, you know, working as an engineer or whatever have you, you know, you're going to get numbers like 3,968 over, you know, 10,432. Okay. Now, the reason why I know that this can be reduced is because I have an even number here and an even number here. Well, what number, you know, how am I going to reduce this? Well, if I start going through that process, the step approach, I'm going to end up doing a lot of math. Whereas if I use a little bit of trial and error and you use a little bit of common sense, I may probably able to figure it out a little bit faster. Okay, and that's the only reason why I do it the way I do. All right. So I'm going to stop here and pick up with problem 2-11 in the next video.